an enormous amount of volcanic ash and gas into the atmosphere and produced fast, super-hot debris flows or pyroclastic flows over the existing landscape. With the underground magma chamber emptying, the ground above it collapsed and created the first of Yellowstone's 3 calderas. This eruption happened 2.1 million years ago and easily ranked among the largest volcanic eruptions known to man. It covered 5,790 square miles with ash, reaching as far away as Missouri. For context, the total volcanic material ejected is estimated to have been 6,000 times the volume of material ejected during the 1980 eruption of Mt. St. Helens in Washington. A second significant volcanic eruption would occur about 800,000 years later. However, it was smaller and occurred within the western edge of the first caldera. A third and last massive volcanic eruption occurred 631,000 years ago and created the present 30 by 44 mile wide Yellowstone caldera. Since then, 80 minor eruptions have occurred, and the one that happened about 174,000 years ago created what is now the west thumb of Yellowstone Lake. During and after these explosive eruptions, massive lava flows of viscous rhyolitic lava and less voluminous basalt lava flows partially filled the caldera floor and surrounding terrain. The youngest of these lava flows is the 70,000-year-old pitchstone rhyolite flow in the southwest corner of Yellowstone National Park. Since the last of 3 caldera-forming eruptions, pressure from the shallow magma body has formed 2 resurgent domes inside the Yellowstone caldera. Magma may be as little as 3 to 8 miles beneath Sour Creek Dome and 8 to 12 miles beneath Mallard Lake Dome, and both domes inflate and subside as the volume of magma or hydrothermal fluids changes beneath them. The entire caldera floor lifts up or subsides too, but not as much as the 2 domes. In the past century, the net inflation has tilted the caldera floor toward the south. As a result, Yellowstone Lake's southern shores have subsided, and trees now stand in water, and the north end of the lake has risen into a sandy beach at Fishing Bridge. Is the Yellowstone volcano active today? The answer is yes. Remarkable ground deformation has been documented along the central axis of the caldera between Old Faithful and White Lake and Pelican Valley in historic time. Surveys of suspected ground deformation began in 1975 using vertical motion surveys of benchmarks in the ground. By 1985 the surveys documented unprecedented uplift of the entire caldera above a meter. Later GPS measurements revealed that the caldera went into an episode of subsidence or sinking until 2005, when the caldera returned to an episode of extreme uplift. The most significant vertical movement was recorded at the White Lake GPS station, inside the caldera's eastern rim, where the total uplift from 2004 to 2010 was about 27 centimeters. However, what happens if Yellowstone's volcano erupts again? The picture isn't pretty. The effect will be felt worldwide, but of course, the closer you are to Yellowstone, the more you are affected. This event can be 1,000 times more powerful than a regular volcanic eruption, eject at least 240 cubic miles of material, and last weeks or months. The lava flows themselves will be contained within a relatively small radius within the park, say, 40 miles or so. In fact, only about 1/3 of the material will end up in the atmosphere. However, the main damage will come from volcanic ash, a combination of splintered rock and glass. This will shoot miles into the air and scatter around the country. A supereruption can conceivably bury the northern Rockies in 3 feet of ash, basically devastating large swaths of Wyoming, Idaho, Colorado, Montana, and Utah. Meanwhile, the Midwest will get a few inches of ash, while both coasts will see even smaller amounts. This volcanic ash is toxic and can kill people, plants, and animals. It will even crush buildings. Even a few inches of ash can destroy farms, clog roadways, cause severe respiratory problems, block sewer lines, and even short out transformers. Air travel will stop in much of North America. What about globally? A big volcanic eruption in Yellowstone will significantly affect the global climate. Volcanoes can emit sulfur aerosols that reflect sunlight back into the atmosphere, cool the climate. Meanwhile, these particles cannot survive for long in the atmosphere, so the effect is only temporary, but it can still be dramatic. For example, when Pinatubo erupted in 1991, it cooled the planet by about 1°C or 1.8 F for a few years. The Tambora eruption in 1815 was worse because it cooled the Earth enough to damage crops around the world, likely causing famines in some areas. Bear in mind that those were relatively tiny eruptions compared to what a supervolcano in Yellowstone is capable of. Globally, the eruption will cause trillions of dollars worth of damage. However,